take input from maybe a file or a stream and write output to a file or stream. Or maybe we have a program. So this program is pretty straightforward. It's similar to the one there's an example in problem set 2. You open a file for reading, you open a file for writing, then your main program essentially cycles through reading stuff out of the file, writing stuff out of the file. So the control flow is pretty straightforward. You start at main, and you do the open, you do the open of the other thing, and then you follow sequentially, just step by step from main. All right? So it's the sort of program flow that you're used to from Scheme in problem set 1. You start at main, and you do a method call, and then you follow that method call, or you do a loop, and the flow of control is pretty clear. We can think of another type of program. Yikes. Where instead of a file, we're talking to the terminal. And so we wait for the user to type a line on the terminal, and then we type something back at the user. This program is pretty much identical in structure to this. As we saw the other day, we have the stream metaphor, which makes us, which can make files and terminals look pretty much the same. So the same program will work in that format, and the flow of control is pretty much the same. We start at main, and we continue through. Now, if we look at our GUI programs that we started to talk about yesterday, I will habitually say GUI for graphic user interface, because it's shorter and it's what everybody does. Think about the flow of control in my Netscape program, which has lots of juicy user interface stuff in it. What's the program doing now when it's kind of quiescent? Basically, it's doing nothing most of the time. But then it's waiting for me to do something. And when I do something, it goes and responds to it. All right? And if I do a click here, it does one thing. If I click here and then type a character, it does a different thing. If I type the same character here, nothing happens. All right? So this is sort of a different sort of user interaction. Now, we could think about, we have sort of a tool for doing this here. We could conceivably hook up some input stream to the keyboard, some input stream to the mouse, and just kind of continue the way we were going before. But there's a problem with that, which I alluded to back when I talked about the properties of read on streams. Basically, read, in its fundamental sense, is a blocking operation. All right? So if there's no input on the stream, you wait for the user. Say, if you're waiting on the terminal, you just block until the user types input. Now, if you have lots of stuff going on, for example, you want to catch mouse buttons, mouse movement, you want to catch keyboard clicks, and you're blocked on one thing, you're going to miss something happening on another channel. If you have lots of channels coming in for input, blocking does not work very well. Okay? So one way to do this is to set up kind of a non-blocking loop, make all your reads non-blocking, and then write this big loop that tests everything all the time, which kind of works but gets messy and results in you spinning a lot and burning a lot of CPU just checking to see when something's happening everywhere. So after puzzling this problem out for a number of years, the people who build Windows systems and software systems came up with a mechanism that seemed to work and everybody kind of converged on. And that mechanism is called event-based programming, or event loops. Okay, and this is basically a means for handling, in its basic state, it's a technology or way of organizing your program to handle input from multiple sources. Okay? It's been really taken to its most extreme development in Windows systems where there are lots of different sources of input that you want to deal with. There's not only the raw events from the mouse and keyboard, but as we'll see Monday, all this technology, all these little things here will look to your program like other input devices. So there's a lot of things to keep track of when we're doing this. So there's many different implementations of this idea. Every Windows system has its own basic one. In Microsoft Windows, there's a event queue system built in. In the Macintosh, the same way. Since X Windows really separates the kind of Windows system component from the programming component to get this distributed network system, there actually have grown up multiple event-based GUI environments around X Windows. And of course, there's the Java environment. Some of the native X ones you may have heard about is Motif, which is a widget set around. There's one in Tickle. It's called, that's the TK part of Tickle TK. I think someone's written one from Perl. So, but they all, once you learn how to use one, you can pretty much get into how to use all of the others. It's just a matter, again, of groveling over massive documentation. OK, so here's the basic idea. It's all the same, and it involves a data structure that you have to know is there, and know kind of what it's trying to do, but not worry about any of the implementation details because it's hidden from you. And it's something called an event queue. Okay, a queue, or a FIFO queue, is a general data structure that behaves like a bunch of people standing in line, in that objects are stuck in one end, and they are pulled off the other end, and they're removed from the other end, and basically they come out in exactly the order, or more or less the order, that they were put in. All right? And an event queue is a queue of event data structures. And so on one end of the event data structure, there's our friend, the operating system, and Windows system. Okay? So the operating system and Windows system, the technology behind everything that's making all of our magic work, are going to do a bunch of work for us here. And what they are going to do is figure out what's going on the screen, what kind of user things have happened, and for everything of interest, it's going to create a data structure called an event. Okay, usually the happening is called an event, and the data structure associated with it is called an event data structure. And what I'm going to talk about for the first, say, 20 minutes is, or the next 20 minutes, is pretty much universal stuff. So I'm not going to worry about exactly how the data structures are represented, but just a basic sketch of it, and I'm going to write things in pseudocode. And then we'll do how Java actually deals with this sort of thing. So you have these event data structures, and the operating system and Windows system generate them when anything interesting happens and put them on this queue. And then over here, you have each program, as a matter of fact, it separates them. And each program generally gets its own event queue. So we'll only worry about the event queue that gets attached to our program. The program basically pulls off events off of the queue. So the program is a sink for events. And we'll talk a little bit about that in a moment. But what is on these events? Okay, there's some key information. One is the source window. As we said, the Windows system conceptually breaks up the screen into rectangular areas And some of them are these large frame areas. Others are these smaller areas which correspond to buttons or drawing areas. Each one of these is a window. And when something happens, the window system is smart enough to assign that to a particular window. So when it makes up this event data structure, it will assign it. One of the things that it'll put inside is it'll store what window it came from. And the other thing it'll store, another thing it'll store is the type of the event. Was it a mouse event? Was it a keyboard event? Was it a mouse click? Was it a mouse press? Was it a key being pushed down, key being pushed up? Was it a window being exposed, a window being iconified, a window covering another window? Okay, lots of different types of events. It just makes a list of the ones it's going to do and stores them someplace. Finally, data. For each type, there's specific data associated with each type. For example, when you have a key press event on the keyboard, what's an interesting piece of data to know? Well, like which key was pressed. When you have a mouse movement event or a mouse click event, what you'd like to know is where the mouse was when the click happened, what the XY coordinates are local to the window. You'd like to know which button on the mouse was clicked. And that's probably about it. For some of these higher level systems, for higher level components, we'll talk about what kinds of more complex events they generate on Monday.
Is there a size limitation on how much data can be in each data event?
Well, since these structures are really defined by the operating system and the Windows system and whatever event system's going on, the user doesn't get to control those. So whoever did the underlying implementation can decide that. Typically, since this is the heart of and soul of the thing, you want that to be efficient. So you don't want to put scads of data in there. All right. And it starts out by doing, its application initialization. Geez, I have too many letters here. And then, okay, so there's a lot of that. And then there's our GUI init. Okay, so far it's just what we're used to seeing. We do stuff sequentially in main, and these can call sub-method, these can do method calls out to objects that do the real work, but nonetheless the control flow goes here. And then it enters basically a loop called the event loop. All right. Now, in some systems, this event loop is very visible to the programmer. In other systems, like Java, it's quite hidden. But this is what I'm going to try and show you what's going on behind the scenes. So this is basically while true. So this just goes forever. And it basically does something like, this is pseudocode in no particular language. And then loops back. So basically, in an event-type program, you do a bunch of setup, then you drop into this loop, and you're in this loop forever. Most event programs will never drop out of that loop until you kill the program. So all this does is do some kind of thing that gets an event, which pulls the next event off the event queue, and then of course, all this magic thing called process event, which does all the program-specific work associated with the event. So now, all of the work of our program is basically done in this process event routine. So how do we write one of these routines? What do they process event routines look like? And again, this depends a little bit on the particular system, but they all pretty much are big switches. Okay, this is some generic process event. Very low level. And it basically does a two-way branch. Okay, so the first thing it does is check on which window it is. So if E dot window, and remember, none of this is real syntax. It's just trying to get at the concept, equals, say, main window. Then we do some set of thing, else, if E dot window equals, say, toolbar window. Then we do some other sort of thing, dot, dot, dot. So this is code for
We only handle the clicks within our window. I mean, if someone clicked outside of our window, like onto some other application.
right, but remember
that's the
there's
OS that deals with it.
what we want to think about is there's events in our frame, okay, which is this big square here, and that's associated with our program. But inside the frame, there's many, many different windows that we have. So we have to deal with stuff that's associated with all of our windows, but none of anybody else's windows, right? But
We don't have to do anything to put ours, our thing to sleep when it goes in the background.
no, the Windows system will do all that for you. Okay, so and now we have to deal with inside this thing that branches on which window they come in. We have to branch on the event type. So we have if ev.type equals mouse click do mouse click in main window. All right? And this is really what it looks like. You basically have this big switch, and at every node in the switch, when you actually figure out what you want to do, you basically call some long routine or some specific routine mouse click in main window, and we'll send that the event, which actually does the work associated with that. All right? So this is really what's going on under the hood of event-driven programs. And the thing that makes it confusing, but at the same time saves you a lot of work in writing, this method in a big program would be page after page after page after page of switch statements, which would be impossible to read. So these systems give you ways to greatly simplify how this process event happens. But as a consequence of that simplification, it hides more and more and more stuff from you. So if you look at what you have to actually write to use one of these things, you sometimes say, what's going on here? And so the moral here is that this is what's going on here. Deep hidden inside the world, there's this loop going on. And we'll see where this gets called in Java in a few minutes. And then there's basically this kind of branching going on where we're actually doing the work. Now, if we use a system like Microsoft Windows using the raw C interface, all right, it hides not very much of this from us. It does hide this outer layer of branching. All right? What Windows will do is it does the process event routine internally, and it does this first level of branching. It takes care of that. So all you have to supply to Windows is for each window, you have to supply a routine that handles all the event types for that window. And that window that is these things are traditionally called WinProcs. So if you read a Windows program, you'll see a lot of things called main window WinProc or my WinProc or whatever. Every time you create a window, you have to make a new routine, call this main window WinProc, and register it with Windows as corresponding to that particular window that you want to process. And when the Windows operating system sees an event coming in on one of these squares, one of these windows, it will route that event and call your WinProc corresponding to that event, and it'll pass in the event type. And then you have to do the next level of switch. You have to switch on the event type. Okay? Java goes one level further and really does both levels of branching for you. It not only does the branching on the window, but it does the branching on the mouse type or the event type for you. So basically, all you have to do is give Java a bunch of routines that handle a bunch of methods that handle that are supposed to handle some event happening in some window, some type of event happening in some window. All right? And a nice thing about this is that it's what is called a subscription model, in that you only have to supply methods for event types in Windows that you're interested in doing something. And if you don't want anything to happen for certain cases, you don't have to give Java anything, and it'll take care of just the underlying mechanism of pulling the events off the queue and ignoring them and all of that. So you don't have to have a bunch of default do-nothing cases. So that is underlying what the Java event system is trying to do. Okay, keeping in mind what we're trying to accomplish, we can look at what the Java syntax is doing. And I'm going to break the discussion down into, there's three things that we have to worry about. We have to worry about the event type, which is that inner layer of branching. We have to worry about the source window. And then we have to worry about the actual handler method, the handler routine. So basically, we have to decide what the code is for our handler routine is, package it up somehow, and then tell the Java window system that when we get this event type in this window, I want to call that method. That's all the system is trying to do. And so we'll start from the Java technology for events. This being Java, events are objects. There's a class called event, which is a superclass. And each major type of mouse event, I keep saying mouse event. Each major type of event has its own subclass of event. So we have a mouse event class, which represents some things happening to the mouse. We have a key event class. We have a window event class, ... We have another one called mouse motion event class. Okay. This one deals with basically clicking type events. This one deals with just moving the mouse around. Sometimes, since it's relatively expensive to pick up these guys, you want to ignore these guys and only pay attention to the mouse when it gets clicked. So, and there's lots of these. And these are all defined by these are all defined in the Java classes, or in the Java system itself. So, all right. So fine. Now we know how to specify events, and at least to a certain extent, specify event types. Let's talk about how to specify our handlers. Let's do a mouse event handler. Java associates with each event type. Okay, each event type in the big sense, and well, say each particular event type in the small sense, like a particular mouse click. Okay, a particular mouse click is an event type. Java associates with that a method, a particular method name in a particular method way that says, if you give me one of these methods, this is what I'll call when mouse click happens. And using the Java technology, the way it specifies that is it gives you a bunch of interface definitions. So it says, here are the routines you have to write. Here are the names of them. Here's what they look like. You go write them. You give them to me. And you make a class that implements this interface. Give it to me. And I'll promise to call these methods back when the right thing happens. And indeed, since we have a bunch of big classes of events, okay, mouse events correspond to, say, a mouse click event, a mouse press event, a mouse enter event. Okay, these are grouped. Each one of these has a corresponding listener. Okay, and these are interfaces. All right, and the mouse listener definition has a bunch of methods on it. The mouse listener has ones called, let's see, mouse click, and it takes a event. Actually, the argument that it's going to give you is mouse event. Yeah. All right, and I believe that's a void. And it also specifies mouse press. I think that's the name of it. I could be wrong. Okay, and it gives you about 6 of these. All right, so to catch mouse events, to write a set of handlers for the mouse, what you do is create a class that implements mouse click, mouse press, all these things. So you want a class that implements mouse listener, gives actual doing things for all of those things, and that's what Java wants from you. All right. Now sometimes you're only interested in the click event and not interested in all the other sub events under the mouse class of events. So Java gives you a utility thing, which is a class called, in this case, mouse adapter. Okay, mouse adapter is nothing magic except a class that implements mouse listener. So somewhere in Java, there's class mouse adapter implements mouse listener, and versions of all these routines that do absolutely nothing. Okay, so if you want to catch mouse events and not do anything with them, you can use this mouse event handler, mouse adapter. The beauty of this is that you can extend it and only overwrite the ones you want. For example, you could do class myMouse extends mouse adapter, and then write void mouse click mouse event system.out.println hi there. And what this will do is every time if you install this or attach this to one of these source windows, what this will do is every time a mouse click happens, it will do a system.println of hi there and basically print hi there. And since println always prints to the console window, it won't print it into your frame. It'll print it on the console window associated with the Java. But this is what the class looks like. This is how you define all of these little handler routines that you might not write, that you have to write, rather. You put them on either a mouse adapter class or a key event adapter or key adapter class. There's a window adapter class, a mouse motion adapter, and each one of these implements mouse listener, key listener, window listener, mouse motion listener. It implements those interfaces with empty events. It's purely a convenience. You could also do class myMouse implements mouse listener, but then I'd have to put like 6 more of these things in. So it's just a mechanism to save you typing. Okay, the last piece is now we know how to write handler methods for particular event types. We have this class that does that. We now have to attach it to a source window. And the technology for doing that is very simple. We figure out which objects, since we have an object, correspond to each one of these windows. For example, in our old example from yesterday, we had my panel. Which makes a new panel window inside of our frame. And there are routines associated with all of these, methods associated with all of these types that we've inherited this from JPanel. And associated with all of these window types, there are basically add listener routines. And there's one for every listener type. So here we have to add mouse listener of new myMouse. Okay? And this makes a new version of myMouse, which has a click handler routine, and sends it off to the panel object, the panel window I created, which basically says to the window system, OK, if you get a mouse click in this panel window, call this routine. Call this method. And that's what happens. So basically, event-based programming consists of writing lots of these methods in these adapter classes, or listener classes, let's call them. So you have to make a bunch of listeners and write all of the handler routines for the methods you're interested in, give them to the right windows, and you're pretty much done. Then you sit back, and the thing just works for you. But if you don't realize what's going on under the hood, it's very mysterious, because instead of writing main and procedure calls from main and regular control flow, you're kind of writing a piece of code here, a piece of code here, a piece of code here, not connected in any way you can see, but then stuff is magically happening all over the place. And the mechanism that's connecting them is this mechanism and this while loop, this loop. Now in Java, this is also hidden from you, almost. We saw it the other day when we did the last thing we did in our program yesterday was frame.show. This does a couple things. It takes this frame and it registers it with the window system, and it makes it visible so you can see it. But then it also drops into this event loop. Okay, so this frame.show is actually the Java system thing that's disguising this event loop. So in Java, we never have to write this thing ourselves. It's all hidden inside frame.show.
That was so that it would close on clicking? Is that what?
Which the...
Yeah, the event handler on.
Oh.
Is that why it had the event handler?
Why we had that magic little thing on the frame also? I'm not sure what you mean by close on clicking.
That's what we're is that that's
right.
What we're seeing the event handler in it. So it recognizes the clicking.
What that does is behind the scenes make one of these event handlers for you that catches the close event. Okay, but the show. Once you enter the show...
Is it using the event handler for anything other than the closing?
Our program, before it was using it for the closing. The other thing it was using it for, remember, we put all of our drawing routines in paint component, not into main.
Okay.
Okay? And who was calling paint component? Okay, that was a mysterious thing. Because, nowhere we had this method defined paint component that clearly was being called, because we could do printfs out of it, and we could see them. But where is it being called from? That's also being called from the event loop. Every time something interesting happens that you have to expose, that an event is propagated and paint component is being called. there's one extra piece of magic going on in the paint component place, because you notice it had to come up with a graphics object for us. So really, there's a little meta event handler that catches the raw event of expose and then goes and finds the right graphics thing. So I think we have covered enough stuff to do it. Let's see, show, frame, and enter event loop. Well, this is the Chinese version of show, I think. All right, there we go. Oh. I hate that insert mode. If anybody knows how to turn off that insert mode, that overstrike mode, let me know. So here is pretty much, where is it? It's not there. Here is pretty much what I drew on the screen, on the board. My my mouse I called mouse handler. We have a class mouse handler. It extends mouse adapter, and I've overwritten two of the methods. Mouse press, which gets called, corresponds to a mouse button being pressed down. Mouse clicked, which corresponds to a mouse button being pressed down and led up within a certain amount of time. So you're thinking, I should get both of these things should be called every time I press, since I click, since I get one for the click, one for the press. And we'll see indeed. And, okay, these get called with the mouse event as input. And the mouse event has certain methods on it, which you can look up in the documentation. But the obvious ones are to get the current position of the mouse, get X, get Y. And all I'm doing here is going to print out what the position of the mouse is when I click it. One more point going back to the concept here. You might ask a couple questions about this design. For example, why is the difference between mouse event and key event divided up into two different classes? Why does Java treat those as two different classes, whereas the distinction between mouse click and mouse press only gets distinguished by different methods in the mouse adapter class? Why don't I have a mouse and keyboard class and have a mouse click, mouse press, key press methods inside? The answer is purely that's just an arbitrary choice that they made. Okay? You could have done one big event class and had lots of different methods. You could have gone the other way and had lots of different classes, each one having one method. They split the difference. Another question you might ask is, why do I need a separate add listener routine for every event type? Why don't I have a single add listener routine and it figures out what type of listener I gave it, because it knows what, it can use introspection to figure out what interface I implemented. And I think that's just more of it being explicit. I think it certainly could have done it the other way. It's probably just it wanting the code to be very explicit as to what you were doing when. So in case you were wondering why they chose things that way, the answer is they just did. All right, so any questions on our mouse handler? OK. Now, somewhere we have to add this to our window, and we just do it in our constructor to JPanel, to the MyPanel. We do add mouse listener of make a new mouse handler and add it. All right, and let's see if we can compile this guy. All right. Actually, since we got that changed on disk thing, I'm actually going to make some change, write it out. Geez, very fussy today. And try and compile it again. And now we'll try and run it. And here is our window with the hello world. I made it in red today. And if I click the button indeed, exactly what happens, what we expect to happen, happens. I get one event for the press, one event for the click, okay? And this method gets called when I do the press. This method gets called when I do the click. And it prints out the x and y coordinates. If I'm here at, say, 198, 198, okay, 197, 197. It prints out that. If I try and get up to like 0, 0, well, 5, 1.
Press and hold, will it still do both click and?
Okay, let's try it. Nope, just press and click. So the click happens. I don't know if click ever times out or whether any down followed by an up gives you a click, apparently. So
If you move,
sure, let's try that. We go here. Oh, look at that. It didn't give me a click. If you press and move and hold it down long enough, it doesn't give you a click. So
if you hold
interesting.
it but don't move it and then release it, does it give you a click?
Yes, if I hold it and don't move it, it does give me a click. So, well, now we know the rules. Huh?
Hold it a bit longer.
All right. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi.
All right.
Wow, look at that. It times out at 5 Mississippi. Or some number of Mississippis less than 5. All right. Now, here's an interesting thing. Why is that interesting? Oh, because I forgot to put in my magic thing that closed the window. I forgot. If you don't do that kill on exit, it basically sticks around. All right. So we're through a lot of my pages. This is good. Yes?
What's the mouse move button? If you just move the event, fire the
Yes. Yes.
If you keep moving, it doesn't keep firing.
Yes. Yes. So the mouse, that's why it's broken out into a separate class. The mouse movement event is highly problematic in that you can generate a SCAD of mouse movement events by doing something like this.
Now, does this sample the mouse based on a certain time increment or based on a certain distance moved increment?
It doesn't, the mouse signals, it doesn't sample the mouse.
Right. The mouse is telling the operating system every time it moves. The operating system is responding to that and generating a SCAD of these guys. Just a SCAD of them. Every time anything happens, it's generating them. Now, the event queue is typically smart in that if you have a whole pile of mouse move events in the event queue, if you have a good event queue manager, it will do movement compression basically. If you have nothing but a string of mouse move events in a row, basically it'll compress those. All right, since the net effect of them all is the mouse used to be here and now the mouse is here, and you don't often care all the intermediate stages, especially if you're running behind in your updating. So the thing will only save the begin point, the end point, and then you can do a big jump in your program. Your program never sees that. So that's what saves you from slowing down enormously in this. But on the other hand, if you do something very complicated, draw something very complicated in your mouse motion handler, you will see it falling behind your mouse, and you'll see your responsiveness slow down. Which brings us to another point, which I should mention. Since what's going on here is this basically while loop, it does, while get event, process event, and process event basically eventually calls one of these guys. What happens if I do a blocking read in one of these event handlers?
You can only take input from that.
Well, say the read actually blocks. So I'm trying to read from the keyboard, from the terminal or some network connection inside one of these guys, and there's no data there. Basically, this routine will block, right? It'll go to sleep inside that routine. Or say I just did a sleep for 5 minutes inside that routine. Since there's nothing magic going on here, we just have this loop. If you do something that either blocks or sleeps or takes up a lot of compute in one of these things, the responsiveness of your program is going to suffer. because as long as it's trying to process this event, it's not going to be processing any other events. And so if you do a key press or whatever, your whole application is going to look like it's locked up, because nothing the user does is going to ever show up until you finish that particular handler routine or any particular handler routine. And then, of course, all those events will come flooding through, and the application will go wild. You must have seen this event on, say, Netscape or an editor sometime, is if sometimes these things do try and do, say, a network file system access, it'll block on a file write or something because the network file system hiccups, and you'll type a bunch of keys because you won't know what's going on, and then finally that handler routine will return, having done what it wants to do, and then all those things that you did when you were trying to figure out what was going on will come crashing through and often cause damage. So the moral of the story is be careful what you do in your handler routines. Make them short, make them sweet, make them fast.
Who defines the size of the event queue? Because we know we're going to expect something that's going to delay it for a while. We're probably going to want a larger event queue so we don't lose events coming in.
The Windows system is going to take care of that, and it's its job to make sure you don't lose events in any case that you're not screwing up so bad that losing events is the least of your problems. So you don't really have explicit control over that. All right, one more issue, which is another conceptually hard issue, but mostly from a technical programming point of view. So far, our mouse handler just prints something out to the console window, and maybe we could have it write something on the screen. But say we wanted to actually interact with our application. How would we do that? In particular, how does this method in this class get access to our application data? Say this current color, all right, which is some application-specific data down in JPanel. All right? How does this guy, these routines, ever get access to this? Well, it doesn't have any instance of MyPanel in here, and we can't pass an instance of MyPanel in because the Windows system calls us, and it's only going to pass in one argument, which is a mouse event. So we're stuck there. What we could do is make this guy static public, okay, and then this guy could have access to it. But that's very bad form. That means that any variables that you would want to be accessed by your mouse events would have to be public and static and accessible to all. Not very good form. So how do we solve this? And in Java, the answer is kind of a technical solution. You use inner classes. And this is really probably why inner classes were invented or imported into Java. It's probably the main use for them, aside from just doing convenient support classes. So what I'm going to do is take my mouse handle class from being an external class to being now a nice inner class. And we'll put a comment, make an inner class so we can access MyPanel data. Okay. Now, the magic about inner classes, which makes them useful in this case, is that a method in an inner class not only has access to any instance variables on itself, say mouse handler, it has access to the instance variables in the enclosing class. So this handler now have access to current. So I can write something like if current equals color dot red, current equals color dot blue, else, big fan of the cut and paste school of programming, red. All right, so now I'm saying every time I click the mouse, if the current color here is red, I'm going to change it to blue. Otherwise, if it's not red, I'm going to set it to red. And since I want to see this change take effect immediately, I'm going to call a method called repaint. And this is a method on JPanel, actually. And what repaint does is essentially send a signal to the Windows system that says I need to call that paint component routine. So it bounces back out and in, and it effectively causes paint component to be called. So this is the whole magic of inner classes here, that this inner class has access to instance variables in the outer class.
What causes mouse handler to be called?
What causes mouse handler to...
Since it's in the inner class now, is it...
You're still adding it there.
Right, I'm still adding it here. I'm still doing exactly what I was doing before, but instead of it being an external class, it's an inner class. Now, one question that maybe relates to that is I said it had access to the instance variables of the surrounding class. The question is, given I have an instance of an inner class, which instance does it have access to of the outer class? And the answer is it has access to the instance variables of the outer class that created it, the instance of the outer class that created it. So here, since I do a new mouse handler every time I do in the constructor for my panel, every time I make a new my panel, I make a new mouse handler, and that mouse handler has access to the instance variables of the my panel I made. It's a little tricky, and it needs a little time to think about it. Another thing, just another syntax that's not required, but there's a keyword that kind of corresponds to this, which points to ourselves, super, which points to our parent in the inheritance hierarchy. There's a magic keyword called outer, which for an inner class points to the instance of the surrounding class, the outer class. So we could have equally well done this. For example, if we had a local instance variable called current, we could distinguish them, the one here and the one up here, by calling the one up here as outer. It's not required, but it should work. So let's go and run that one again. Well, okay, maybe it didn't like it. Else outer, local variable outer. That's weird. All right, forget what I just said. That should have worked. So let's see if I don't have any typos. All right, it has the behavior I expect. Every time I click on or press the mouse, in this case, if the current color is red, it switches it to blue, causes repaint, which causes a redraw, which which draws hello world. And if you will notice down in my hello, before the drawstring to hello world, I do a set color to current. So whatever the current color is. And I have something that goes back and forth.
Blue, red, blue, red.
Blue, red, blue, red. Ting, 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 ting. Well, cool. That's all there is really to event handling. Wow, I went so fast because I think I was going to go long, then ended up finishing early. So I'll say a couple other things. We did an example of handling mouse press and mouse click events on the by defining mouse handler. There's, as I say, another probably 6 or 8 event classes, and each one of those has maybe 3 or 4 event types on them. So you've probably got a selection of maybe 20 events to handle in your in just the basic interaction with the Windows system, the mouse, the keyboard. Okay, all that handling is done this way. Use inner classes to share data between your handler routines and your application. Let's see. One other comment is that although, as I said, this sort of system has really come to its highest development in GUI application programming, the underlying paradigm actually turns out to be useful in a lot of different programming situations. You might find yourself, doing some application that, is getting sort of information or procedure calls or input from a lot of different sources that you want to be able to serialize and then deal with in an organized way. And one paradigm to fall back on is to implement one of these things. Even though most systems, if you do a GUI system, it's all hidden from you and implemented for you, there's nothing to prevent you, if you're given, a raw chunk of hardware and told to make something work, there's nothing to prevent you from implementing the whole event queue yourself. It's nothing particularly hard about it. You can implement that data structure, that loop, and it should all work. It's just a matter of a lot of effort. Let's see, one more thing. If we think about this application for a moment, what we have here is a square area that when I click, it, in this case, redraws itself in a different way, but basically does something on when I do a click on it in this particular area. Now, if you think of that as at a higher level construct, that's a button. Okay, it's more or less the behavior of one of these guys. Okay, when I click on it, it's going to redraw itself in a different way, and then go and do something. In this case, something bad, since we don't have a network. But so one of the things we could do is start, thinking about building up higher level constructs from these basic event handler things. And indeed, people 10 years ago have thought about doing this for us and have given us whole libraries of components that will process primitive events for us, do interesting screen update, and then bounce back when we need to know higher level type events. Okay, there's an event class called action event. And the methods on action event and some of its cousins, text event and update event, are not coming from raw pieces of hardware like the mouse, but they're coming from these library functions that capture the raw events, do some complicated processing, and every once in a while, when the program needs to be informed, gives us information back. For example, this kind of scroll bar system, that whole mechanism that basically notices when I press the mouse, that moves this bar around, it moves this around, and stops when I lift up the mouse. Okay, all that event handling is all handled inside some handy library function for us. We never have to, at the lowest level, catch all of the events. But then every once in a while, you might want to know what you might want to know what's happening or catch particular things. For example, if I click on an anchor in here, in which case you might want to get a higher level callback that only occurs when I click on an anchor. And that's what these libraries of things do. They're called components, GUI components, or widgets often. And that's what we're going to talk about starting Monday. Yes?
If you have something complicated you want to do related to a mouse event, say you were writing a spreadsheet and you wanted to have a button for recalculate this whole thing,
Mm-hmm.
is there a way to prevent it from then just hanging until it's done?
Yes, there is. And if you're just recalculating a bunch of stuff, it's probably going to be fast enough that you don't have to worry about it.
Right.
If you're doing something really computational intensive, there's a way of essentially saying, do this in the background while I'm doing other things. And there's a mechanism called threads, which we'll talk about next week. So that allows you to build parallelism into your program.
When you say Monday, do you mean
Tuesday, yes. When I say Monday, I mean Tuesday. Yes. That's not a general rule. That's just for this week. Any other questions? You will have to try all this stuff out for the game, yes?
I don't know about other people, but I got lost when you talked about interfaces here.
Okay.
And in general, an interface, you have to do all the
Right.
rewrite everything that's
Right.
in there. And,
Right.
But this one, you're saying you don't.
You
I
don't
lost that
because,
connection.
okay, you don't because it's such a pain, Java gives you a special set of classes called adapters.
And it's the adapter that implements.
Right.
Okay.
So adapter implements these, mouse adapter implements mouse listener with a bunch of empty routines.
Okay.
So that way,
you just extend
exactly.
mouse adapter, and through that you implement.
Exactly.
Okay.
So you basically you get to override the ones you care about. The empty the empty implementations on mouse adapter get carried through, and so people who expect a listener are happy, and you're happy, and everybody's happy. Hey, have a nice 3-day weekend, and we'll see you Tuesday.